All right, welcome back. We're getting near the end of this unit. This is kind of like the last bulk of stuff we're going to be doing. So Unit 6, we are on page 31 of your notes. We're going to be dealing with the two special triangles that you started working with in geometry, the 30-16-90 and the 45-45-90. But they're going to be kind of modified a little bit based on what you did in geometry. So we're going to start with that. All right, so what are the ratios of the sides in the 30-16-90? So from geometry, from geo, you did the side across from the 30 was x or 1x. The side across from the 60 is x root 3. Sorry, not writing real well. And the side across from the 90 is the 2x side. All right, so from a geometry perspective, if I took this over here, the side across from 30 would be x or 1x. The side across from 60 would be x root 3, and the hypotenuse would be 2x. All right, but since we're going to be working in the unit circle, so use the fact that the radius of the unit circle, which equals 1, represents the value of the hypotenuse of the triangle. Solve for x and find the value of each side. So we want unit circle, we want the radius to always equal 1 because it's honestly the easiest to work with. So what means is that's the hypotenuse. So the hypotenuse we want ultimately to equal 1. So no x is involved, no other number. So really what's going to happen is we're going to divide by 2x, but if I divide that, I'm going to divide everything by 2x. And I'm going to simplify. So when the radius is equal to 1, the side across from the 30 simplifies to 1/2 because the x's cancel out. And the side across from the 60 simplifies to root 3 over 2. X's cancel out again, and so you have the root 3 over 2. So for trig, so geometry, this was the thing for the 30-60-90. The side across from the 30 is always 1/2. The side across from 60 is root 3 over 2. And the radius is always the hypotenuse, and you get a value of 1. And I'll show you how this is going to work in the unit circle in just a minute. Now the same thing happens for the 45-45-90, where in geo, across from the 45 was x, and 90 was x root 2. Okay, so since this is a 45-45-90, this is isosceles. So this is x, and the hypotenuse is x root 2. Alright, so again, use the fact that the radius in the unit circle, which equals 1, represents the value of the hypotenuse in the triangle. Solve for x and find the value of each side. So in this, we want it to equal 1. So we divide by the same thing again. We divide by whatever it was. Up here we divided by 2x because we want that to be 1. For this one we would divide by x root 2. So this is divide by x root 2 and divide by x root 2. Now of course the nice thing about this is if you know one of these sides you automatically know the other. Alright, so this automatically simplifies to 1 over root 2, which is just the 1x over x root 2, so the x's cancel, so you get that. But rationalize, so if I multiply top and bottom by root 2, I automatically get root 2 over 2. So because this bottom side and the left side started the same thing, they're going to end up being the same thing because it's isosceles. Alright, so for geometry we had x root 2. For trig we have root 2 over 2, root 2 over 2, and 1. So that was the 45-45-90. Alright, so because we're going to take that to the unit circle, in the unit circle the radius is always 1. The radius will represent the hypotenuse of the right triangle. Using this information, we can fill out the corners around the unit circle, but we need to remember the signs. This is going to be important because we're going to have positive and negative signs for the x and y coordinates, depending on where we are. Now, the first quadrant, you have a positive x, positive y. Second quadrant, you have a negative x, positive y, because we go up. Third quadrant is negative and negative. And the fourth quadrant is positive and negative. Now, this is nothing new, but it's actually going to work with the coordinates we're going to get. So we're not talking about the radians or the degrees. We're talking about the x and y coordinates on that. All right, so flip to the next page. All right, so some of the stuff we're going to get, so you see we have 30, 45, this. We're going to have 30, 60, 90 triangles. We're going to have 45, 45, 90. We're going to have 60, 30 triangles, 90 triangles. All right, but first of all, when I go this, and I go out to here, my radius is equal to 1. The coordinates over here are 1 and 0. That's nothing new. So when I go up to 90 from the origin, this is 0, 1. When I go left here, this is -1, 0. And when I go down, this is 0, -1. Okay, that's nothing new. All right, so when they have all these 30, 45, 60 things, this means that the triangle drawn from here, or the angle from here, is 30 coming out right there. Okay, so I'm not going to ask you to draw a triangle each time you do these, but this is where it comes from. So I'm trying to get rid of this so you can see. Now here's my radius. So you have a 30, a 60, and I drop down the side so we have a 90 there. Okay, so across from the 30 is 1/2. Across from the 60 is √3/2. Now this is the x and this is the y. So when you have a 30-degree angle, the coordinates for that is √3/2 and 1/2. And I could keep making these all hung, but this would be really obnoxious to have another triangle and then a third triangle in here. So just trying to show you so that when you have I'll draw it down here. When you have the 45-degree angle, so you have a 45. Gonna drop down, so you have that. So it means you have a 45 there, you have a 90 there, and 45 there. We're using this stuff from the other side, which is √2/2 and √2/2. So your x coordinate and your y coordinate are both the same, which is always very nice. √2/2, √2/2. Now the thing is, these are all the patterns you have. You just got to pay attention to what they are. When you have a 60-degree angle, that means coming from the origin at 60. All that means is this triangle was switched. So the 60 is here and the 30 is here, which means the x's and y's are just switched. So it's 1/2 and √3/2. So if you know 30, or you can figure out 30, you just switch it to get the 60. And the other thing is, these are all symmetric. So all we need to do is take this information and bring it over here. Okay. Now the thing is, when we go into quadrant 2, you have a negative for x and a positive for y when you put your information in. Sorry, these are ordered pairs. When you do this, it's a negative x and a positive y. When you do this, it's negative x and a positive y. Alright, so for this 120, I take the information from the 60 and just bring it over. It's -1/2 √3/2. For the 135, I bring over the 45, √2/2, √2/2. For the 150, I bring over the 30, √3/2 and 1/2. And then everything just kind of like folds down as symmetric here. Now you just got to remember again, third quadrant, negative, negative. Alright, so this one comes down here, √3/2, negative √3/2, -1/2. Then the 45 one comes out, √2/2, negative √2/2. This one, -1/2, negative root 3 over 2. Same thing here. You can either bring these over or flop these on down here. So this 30 up here brings this 30 here. So we have a positive for x but a negative for y. So bring the 30 down because this is negative 30. So root 3 over 2 and negative 1/2. Positive root 2 over 2, negative root 2 over 2. And then 1/2, negative root 3 over 2. Alright, that's a lot of information about how to get these. We're going to talk more about this tomorrow. Now the other thing so I want you to remember and kind of keep track of, when we start doing this information, when we start having x's and y's, cosine is the first order pair and sine is the second order pair. Tangent, which is opposite over adjacent, is sine over cos or y over x. Okay, we'll finish the rest of this tomorrow. Thanks. Talk to you later. Bye.